If we shift our perspective and look toward the object called 3I, Atlas, it's not just another comet. It's more like a sudden cosmic test paper. But this exam isn't about physics or chemistry. It's about the resilience of civilization itself. Because this challenge came without warning. It was first detected in July 2025, and the best observation window will come in early October, giving us less than 100 days to prepare. We'll have to coordinate all of Earth's telescopes at once, even Hubble and the Solar Orbiter will join the effort, and some even suggest redirecting probes near Jupiter to briefly turn and take a look at this interstellar traveler. This doesn't follow the usual rhythm of science. It feels more like an emergency drill. Imagine this. Human civilization is like a student dozing off in class, fast asleep at their desk, when suddenly the teacher drops an unfamiliar test paper on the desk. Across the top are a few bold words: Interstellar Visitor Observation. Below it reads, submit within 3 months, and so, astronomers around the world immediately tense up, like students jolted awake by the school bell, grabbing their pens and rushing to answer. From the infrared data of the James Webb Space Telescope to optical imaging by Hubble, from Mars Express to China's Astronomy 1, every instrument must be recalibrated in record time, rewriting their observation schedules overnight. That's why the arrival of 3I, Atlas, is far more than just a scientific discovery. It's as if some cold, distant examiner has tossed the test paper onto our desk, then stares down silently and asks, Earth civilization, are you ready? To grasp how hard this test really is, we first need to ask a deeper question. Where did this examiner come from? Scientists could tell at a glance. This object doesn't belong here. Its orbit practically shouts, I am an outsider. 3I. Atlas is moving at an astonishing speed, so fast that even the sun's gravity can't hold it. It's not following a normal elliptical orbit, but a classic hyperbolic trajectory. That means it's only passing through once, and will never return, like a stranger opening the door, giving you a cold glance, then walking out without ever looking back. Even more surprising, its path points toward the galactic disk behind the Milky Way, a region filled with stars, most of them older than our sun. In other words, this small celestial body may be older than our entire solar system itself. You can think of it as a bullet fired from ancient times, born in some distant star system, launched by an immense gravitational force, beginning a journey that spanned billions of years, traveling through the darkness between countless stars, wandering quietly through calm interstellar space, until today, when, by sheer coincidence, it passed through our solar system, like a galactic letter delayed for billions of years, finally delivered to our cosmic doorstep. The question now is, what kind of paper is this letter written on? What secrets are hidden inside? The scientist's first reaction was to examine its chemical makeup, because chemistry is like the handwriting on the letter. It tells us where it came from. When the James Webb Space Telescope aimed its infrared spectrometer directly at 3I, Atlas, scientists thought, finally we can read the handwriting clearly. They expected to see the usual pattern. In the comets of our solar system, chemical composition is predictable. Water always takes the lead, while carbon dioxide, methane, and carbon monoxide play only minor roles. But when Webb's data came in, the entire astronomical community was stunned. 3I, Atlas revealed a composition so strange. Carbon dioxide levels were 8 times higher than water. What does that even mean? It's like ordering a glass of water at a restaurant, and the waiter brings you a whole bottle of soda instead. The bubbles go wild. Water is merely background. In our solar system, we've studied thousands of comets, and we've never seen anything like this. A landslide victory for carbon dioxide, unheard of. Even the famously odd comet C2016R2, which had high carbon monoxide levels, still looks tame compared to 3I, Atlas. That was just a mild curiosity, But this interstellar visitor has shattered every record of human observation. So scientists began to brainstorm. Why is it so unusual? The first hypothesis: it may have formed near the carbon dioxide ice line in its parent star system. The so-called ice line marks how far from a star different materials can cool and freeze. He was on an interstellar journey, bombarded again and again by cosmic rays and stellar storms. His surface chemistry slowly began to change. The water molecules may have vanished long ago. What's left behind is stubborn carbon dioxide, clinging like a fossil sealed in a magic stone. In the end, only the hardest skeleton remains. Another hypothesis says, maybe he's wrapped in a thick insulating shell, sealing the water firmly inside. Now, it's only the outer gas leaking out like a cracked high-pressure tank. The most active gas bursts first, while the water stays trapped within, released only when he nears the sun. It all sounds reasonable. But here's the thing. None of these ideas truly satisfy scientists. Because no matter which explanation turns out true, 3I, Atlas's chemistry, tells a story that's completely different from our textbook solar system. And what's even more shocking, when they measured the carbon isotope ratio, they found something extraordinary. His carbon-12 to carbon-13 ratio is almost identical to Earth's, as if you drank a strange cosmic cocktail. Bizarre and alien, yet somehow, in the final sip, you taste something familiar. This complicates everything. 3I Atlas, is it a foreign visitor from an unknown system? Or a distant cousin, disguised in strange cosmic clothing, but secretly a relative of our own? On July 21st, 2025, from 277 million miles away, Hubble captured high-definition images of Atlas. And it turned out, he wasn't a glowing sphere, but a teardrop wrapped in dust, like a single weeping eye. And even stranger, this tear stretched toward the sun. But according to every astronomy textbook, a comet's tail should always point away from the sun. That's Astronomy 101. Solar pressure and solar wind push dust and gas outward, so the tail always faces back. But Atlas defied the rule. His tail away from the sun was barely visible, while the dust facing the sun shone brilliantly, like a backlit flame. It looked like someone crying, but their tears flowed toward the light. Scientists first blamed geometry. Maybe we're just facing him head-on, seeing a stream of dust illuminated by sunlight, like driving at night, and a car's high beam suddenly hit you, a flash straight through your vision. But another possibility is far more intriguing. This could be the first time Atlas has come close to a star in 10,000 years. He may have been sleeping in icy darkness, never once touched by light, until now. And as the sun's heat kissed his surface, his reaction exploded, dust bursting like tears. It's strange and somehow sad, almost as if he were crying for the journey he's about to end. But if we look further, we'll see Atlas isn't the only unruly interstellar guest. Comet Borisov had a normal tail, yet showed an unusually high level of carbon monoxide. And Atlas shed tears of light itself. 3 visitors from the stars, and none of them behaved like the textbook says. Could this hint at a deeper pattern? Maybe star wanderers have their own rules, a shared evolutionary path, a hidden signature that marks them all, like discovering 3 strangers from distant lands, who all share one odd habit. Each one writes with their left hand. You can't help but wonder, what's behind that similarity? If the answer is yes, then Atlas's luminous tears might be the shared emblem of every galactic wanderer. But we must confirm this sign, and Earth's view alone won't be enough. Luckily, the universe gave us a perfect chance. On October 3rd, 2025, Atlas will pass Mars at a distance of just 18 million miles. That might sound far, but in interstellar terms, it's a once-in-a-lifetime encounter. And this changes everything. Mars becomes the frontline base for observing this cosmic traveler. Because even the best Earth telescopes are limited by atmosphere and angle. But orbiting Mars, we already have a whole fleet of instruments waiting. Europe's Mars Express activated its high-resolution camera. The ExoMars orbiter captured gas spectra from the dust. NASA's MAVEN and Mars Reconnaissance Orbiter joined in, repurposing their atmospheric sensors for Comet data. Even Japan and the UAE's Mars missions joined the watch. For a moment, Mars became a temporary observatory, fully armed and aimed at this interstellar visitor. For the first time in human history, we weren't watching from Earth, but from the orbit of another planet, chasing a traveler from the edge of the galaxy. Some scientists called this Operation Interstellar, because one day, when we send true interceptors to chase interstellar objects head-on, we'll need this kind of planetary teamwork across nations, across worlds, and Atlas gave us the perfect rehearsal. Imagine next time, if it's not just a cold stone, but an asteroid with traces of life, or even an alien probe. Could humanity respond fast enough? Could we build an interplanetary network in just a few short months? 3I Atlas acts like a mirror, reflecting not just the mysteries of the stars, but our own readiness for the unknown. And every interstellar visitor sparks the same debate, science versus wonder. In 2017, Oumuamua, the mysterious cigar-shaped object, showed unexplained acceleration. Harvard's Avi Loeb boldly proposed it could be an alien probe. The idea split the scientific world, but it made humanity seriously consider extraterrestrial technology for the first time. Now Atlas and its teardrop glow stir that same question again. Why does its dust flow toward the sun? Why are its chemical ratios so strange? Could it be a trace of intelligent design? Could it be a signal from somewhere else? We're watching a signal sweep across the galaxy. And if this were a science fiction movie, of course the plot would lead to the end of the world. But the logic of real science is far calmer. In Hubble's image, it does have a normal tail, just a faint one. And that so-called bright light at its front, there are plausible geometric explanations for it as. For its high proportion of carbon dioxide, there are at least 3 natural mechanisms that could explain it. And here's the thing. Its orbit follows the laws of gravity perfectly. There are no sudden turns, no mysterious slowdowns. In other words, it flies exactly like an ordinary rock. If this truly were an alien spacecraft, then its pilot would be far too professional at pretending. However, that doesn't mean these romantic theories are meaningless. On the contrary, they act like a mirror, reflecting 2 sides of how humanity faces the unknown. One side seeks rational verification, data, logic, and evidence to find the truth. The other side can't help but imagine what if. Science demands a cool head. But civilization survives because of those who dream wildly. Without rational proof, we could never uncover truth. Without romantic imagination, we would lose the courage to look up at the stars. And 3I, Atlas, has once again become the stage where these 2 attitudes collide. Of course, no matter how intense the debate grows, one fact remains unchanged. So far, everything we know about 3I, Atlas comes only from distant spectra and photographs. It's like receiving fleeting messages from a stranger thousands of miles away. You'll never truly know in their life. If we want real answers, and there's only one way, we must send a probe to intercept it head-on. That's exactly the mission goal of the European Space Agency's collaboration with Japan, the Comet Interceptor. Unlike previous space missions, it doesn't aim at a known target. Instead, it will wait patiently at a fixed location, the Sun-Earth Lagrange point, like a hunter holding his breath. Sword always drawn. The moment a new interstellar visitor appears, it will ignite its engines and charge forward, releasing small probes to fly around and sample from multiple angles. This is humanity's first Allegro force in the making. Because we've finally realized that interstellar visitors don't give you time to prepare. They appear like surprise exams, detected only months before their closest pass. To seize the opportunity, we must always be ready. Even more ambitious visions imagine a long-lived interstellar probe stationed at the edge of the solar system, waiting in ambush for these cosmic travelers. It sounds like science fiction, but remember, decades ago humanity had never even detected an exoplanet. Now we've confirmed more than 5,000 of them. The pace of technology always outstrips imagination. So, the true revelation of 3I, Atlas, may not lie in its own mystery, but in what it teaches us. Humanity needs a permanent interstellar response force. But when we speak of a response force, we shouldn't forget the metaphor behind it. 3I. Atlas is like a cold, silent examiner, suddenly tossing a test paper onto our desk. And on that paper, the question isn't just a multiple-choice problem in astronomy. It's an essay question for all of human civilization. What is that question? It's simple. When the unknown suddenly arrives, are we ready? The comet's unusual carbon dioxide ratio reminds us the chemistry of the universe is far more complex than we imagined. Its teardrop-shaped form reminds us, interstellar. Visitors don't follow the rules written in our textbooks. Its orbit and origin, like a galactic letter drifting for billions of years, show us another possibility beyond the solar system. And what about humanity's response? We turned Hubble and other telescopes toward it from Earth. We launched new observations from Mars orbit. We even considered redirecting a probe near Jupiter to take a look. In just a few months, all of humanity carried out a spontaneous, interplanetary exercise. That exercise itself may be the greatest legacy that 3I, Atlas, leaves behind. It taught us a humbling truth. The universe will not wait for you to be ready. It won't ask the same question twice. Every interstellar visitor is a surprise exam, and if you miss it, there's no makeup test. So the real question isn't what this comet is, but whether we'll be ready when the next visitor arrives. It may carry the seeds of life and/or secrets that could rewrite everything we know. And perhaps, in some far future, we'll finally encounter a truly artificial visitor, a manufactured alien craft. When that moment comes, our challenge won't just be scientific. It will be philosophical. It will be about the future of humanity itself. 3I, Atlas, will eventually vanish into the dark. But what it leaves behind is a question mark written across the universe. And the answer is up to us to write.